Hey students, welcome to another chemistry lesson, and today we're going to learn about electron arrangement. Also, we're going to learn about valency and chemical formula. Those three areas are very important in chemistry, and for most students you find that they don't understand valency, and if you don't understand valency, then it becomes very difficult to write chemical formula, because as you write a chemical formula you need to use valency. Now I am not going to waste time. I'm going straight to what we're going to learn, because I have about 10 minutes for this lesson, but I'm going to ask that you subscribe to this channel. So students, let's begin from electron arrangement, and I'm going to go straight to the first 20 elements, because we need to know the electron arrangement for the first 20 elements, and also the valency for these elements, and also even go ahead and know what radicals are and the valency of a radical. So in the periodic table, which we did in our last class, we said that we have so many elements. We have around 118 elements, but I want you to concentrate more on the first 20 elements. Now the first element in the periodic table is hydrogen, and because it is the first element, it means it has atomic number 1, so therefore it has 1 electron, and the electron arrangement for hydrogen is 1, just 1, because it has 1 electron, just 1 electron and 1 proton. So that's what it means. So electron arrangement is 1. Number 2 is helium. Helium is number 2 in the periodic table, therefore the electron arrangement is 2, just 2. And that electron arrangement is called duplet state. That is a duplet state. Duplet means 2. Number 3 is lithium. Electron arrangement is 2-1. Now I want you to know that the first energy level carries a maximum of 2 electrons, and the second energy level carries a maximum of 8 electrons, while the third energy level carries a maximum of 8 electrons, just like the second. But sometimes, if it is an element above 20, atomic number 20, the third energy level carries a maximum of 18 electrons. So that's what I want you to know. Now lithium is atomic number 3, therefore the electron arrangement is 2-1. Beryllium is number 4, so therefore the arrangement in that case, there are 4 electrons, so it's 2.2. So because there are 4 electrons. For boron, which is number 5, the arrangement is 2-3, making 5 electrons. Carbon is 2-4, because carbon is number 6. So it's 2, and then the remaining 4 electrons go to the second energy level. For nitrogen, which is atomic number 7, the electron arrangement is 2-5. For oxygen, which is atomic number 8, the electron arrangement is 2-6. Fluorine is atomic number 9, therefore it's 2-7. And neon, which is atomic number 10, is 2-8. So you can see what is happening there. We arrange the electrons in such a way that the first energy level takes a maximum of 2, and the second energy level takes a maximum of 8. So neon, which is number 10, the electron configuration should be 2, remaining 8 goes to the second energy level. Then let's go on. Atomic number 11 is sodium. So because it has 11 electrons, we are going to arrange these electrons like this: 2, 8, and the remaining 1 goes to the third energy level. So sodium has got 3 energy levels, and the electron arrangement is 2-8-1. Moving on, we have magnesium, which is atomic number 12. The electron arrangement is 2-8-2. Moving on, aluminium is atomic number 13. Therefore, arrangement is 2-8-3, because it is atomic number 13. Atomic number 14 is silicon, so the electron arrangement is 2-8-4. So because the number of electrons are 14, so 2 in the first energy level, 8 in the second, and the remaining 4 goes to the third energy level. So electron arrangement for silicon is 284. Phosphorus is atomic number 15. The arrangement is 285. Very simple. Sulfur is atomic number 16. So the arrangement is 286. And chlorine is number 17. That's 287. That makes 17. Argon is atomic number 18. The arrangement is 288. Now if you look at helium, neon, and argon, helium has 2 energy. It has 2 electrons only, so the arrangement is 2. It has a duplet state. Neon is atomic number 10 with an arrangement of 28. So it has 8 electrons in the outermost energy level. It is stable with an octet state. And also argon 288. It is also stable. Argon is also stable with an octet state of 288. So those ones that I've talked about, helium, neon, and argon, they are stable. We call them noble gases. They are stable, hence they do not react easily. Moving on, we have potassium, which is atomic number 19 with an arrangement of 2881. That makes 19. So therefore, potassium has 4 energy levels. Moving on, we have calcium, which is atomic number 20 with an arrangement of 2882. That makes 20. And calcium also has 4 energy levels. So those are the electron arrangements and configurations for the first 20 elements, and that is how they should be written at all times, all the time. Those are the electron arrangements for the first 20 elements. Now, having talked about electron arrangement, and you have understood how we arrange the electrons in the various energy levels, I want us to talk about valency. Now students, valency is a very important term. It refers to the number of electrons an atom loses or gains during a chemical reaction. The number of electrons an atom gains or loses during a chemical reaction, that is the valency of that element or that atom. Now also valency is also referred to as the combining power of an element. The combining power of an element. Simply the number of electrons an atom is going to lose or gain during a reaction. Now, if you can remember, we have chemical families that we talked about. We have group 1 elements, we have group 2 elements, we have group 7 elements, and so forth and so forth. So I want you to know therefore that all group 1 elements have a valency of 1. For example, sodium has a valency of 1 because sodium is atomic number 11 and it has an arrangement of 281. Therefore, in a chemical reaction, sodium will lose 1 electron. Therefore, the valency is 1. Now, all group 2 elements have a valency of 2. They have a valency of 2, e.g. magnesium. Now, magnesium is atomic number 12. The electron arrangement is 282. Therefore, you can see that magnesium has 2 electrons in the outermost energy level. Therefore, it loses 2 electrons during a reaction. Therefore, the valency for magnesium is 2. Now, if you look at group 7 elements like fluorine and chlorine, they have 7 electrons in the outermost energy level. Therefore, it means that for fluorine to be stable, it needs to gain an electron, not to lose, but to gain 1 electron. So therefore, fluorine will gain 1 electron to become stable, and chlorine will also need to gain 1 electron to become stable. So therefore, for group 7 elements, their valency is 1. They gain 1 electron. Now, group 1 elements like sodium, they lose 1 electron. So there is a difference between group 1 and group 7, though the valency is the same. Now, I want us to talk about some elements which have variable valencies. Now, some elements like iron, which is above 20. If you look at your periodic table, ensure you get the atomic number for iron. Iron has got a valency of 2, so we have ion 2, or it can have a valency of 3, so we have ion 3. So we can have ion 2 ion and ion 3 ion. Copper also has 2 valencies. We have copper 1 and copper 2. So we have copper 1 ion and we have copper 2 ion. Now lead also has 2 valencies. It has a valency of 2 or 4. So we can have lead 2 ion or lead 4 ion. Ensure you pay attention to those that I have mentioned. The 3 elements, iron, copper and lead, they have variable valencies, and we usually learn about them. And especially when we are writing chemical equations, we encounter these elements so many times. So ensure you know the valencies, they keep varying. So copper has 2 valencies, 1 or 2. We have lead has a valency of 2 or 4, and iron can have a valency of 2 or 3. That is very, very important. Now let us move on and talk about something which is related to valency, which is called oxidation number. Now, for most students, oxidation number is the same as valency. Okay, that is correct in one way and it is wrong in another. Now, what I can say is that valency is the number of electrons an atom loses or gains during a chemical reaction. Now, oxidation number is the apparent charge of an atom. The apparent charge of an atom or an ion. Now, what I'm trying to say is that oxidation number or oxidation state, sometimes it is used as valency, it is used interchangeably as valency. Valency and oxidation state go hand in hand. So don't worry, as I'm going to give you an example later on the same. Now, having said that, I want to say something very, very important. When you look at an atom of an element, usually an atom of an element which has not undergone any reaction, the valency or the oxidation state of that atom is 0. But if an atom reacts, if an element reacts, it gains a new valency or it gains a new oxidation state. It gains a new oxidation number. So remember, an atom that has not reacted has no valency. The valency or oxidation state is 0. But if this atom reacts, it gains a new oxidation number. It gains a new oxidation state. And that is very important. Let's look at an example. If sodium reacts, it loses 1 electron. Therefore, it gains a new oxidation number of 1. So the oxidation number of a sodium ion is 1, positive 1. If magnesium reacts, it loses 2 electrons. Therefore, it gains a new oxidation state of positive 2. So that is also the same as the valency, like I've indicated before. Now, having said that, I want us to move on and talk about something that I cannot leave unmentioned, and this one concerns the radicals. Radicals. Now, radicals are groups of atoms with a net charge that exist and react as a unit during a chemical reaction. So in chemistry, radicals are groups of atoms which have a net charge and they exist and react as a unit during a chemical reaction. The valency of a radical is equal to its charge. Now, radicals include, examples of radicals include sulfate ions. The sulfate ion, SO4 negative 2. So the charge of a sulfate radical is negative 2 and it has a valency of 2. Another example of a radical is the carbonate ions, the carbonate ions. The carbonate ion has a chemical formula of CO3 with a negative charge of 2. So the valency of a carbonate is 2. Also, a sulfite ion, SO3 with a negative 2. The valency of a sulfite ion is negative 2. So the valency is 2, or the oxidation number is 2, minus 2. Now, we also have other radicals like ammonium ion, NH4 plus, hydroxide ion, which is OH negative 1. We also have nitrate ions, NO3 negative 1. We have the bicarbonate ions or hydrogen carbonate ions, HCO3 negative 1. We have the bisulfite ions, the hydrogen sulfite ion, which is HSO3 negative 1. We have the hydrogen sulfate ion, which is HSO4. So remember, the bisulfite or the hydrogen sulfite ion is HSO3 negative 1, but the hydrogen sulfate is hydrogen sulfate HSO4 with a negative 1. So they have a valency of 1. And we also have a nitrite ion, which is NO2 negative 1. Remember, a nitrate ion is NO3 negative 1. So a nitrate and a nitrite, they almost look the same, but the difference is the number of oxygen atoms. A nitrate has 3 and a nitrite has 2. We also have a radical that is called a phosphate, and this one is PO4 3 minus. So a phosphate has a valency of 3, therefore the oxidation state is minus 3. We also have the ethanoate ion, from ethanoic acid. When ethanoic acid undergoes ionization, it forms the ethanoate ion or the acetate ion, which is CH3COO negative 1. It has a negative 1. We also have the oxalate ion. The oxalate ion is C2O4 negative 2. The oxalate ion from oxalic acid. We also have the dichromate ion, CR2O7 and negative 2. So the valence is 2. The oxidation number is negative 2. So remember, oxidation number has a sign, a positive sign or a negative sign, but the valency is just a number. For example, the dichromate ion CR2O7 has a valency of 2 and an oxidation number of negative 2. So that is how you can differentiate valency and oxidation number, but they almost look the same. They are used interchangeably. Having talked about these very important radicals, compounds, I want us to move on and we talk about something very important, chemical formula. Now, having understood valency, then you can use these valencies to write the correct chemical formula of a compound. For example, let's move on and look at how we can write the chemical formula for ammonium sulfate. Now, we know that ammonium radical has a valency of 1 and sulfate radical has a valency of 2. Therefore, for you to write the chemical formula for ammonium sulfate, you interchange the valencies. So 2 goes to ammonium and 1 goes to sulfate, and once you interchange that, you will get ammonium sulfate as NH4 brackets 2SO4. So you have to use a bracket when you are writing that 2, and you ignore the 1. 1 does not have a big difference on the chemical formula, so you ignore. Then let's look at how you can write the chemical formula for calcium hydroxide. Calcium has a valency of 2 and hydroxide has a valency of 1. So when you interchange the two valencies, 2 goes to hydroxide and 1 goes to calcium. Therefore, calcium hydroxide is written as calcium OH brackets 2. So you have to use a bracket and put 2 for the hydroxides. We have 2 hydroxide ions for each calcium ion. Let us write the chemical formula for sodium carbonate. Now remember, sodium has a valency of 1 and the carbonate radical has a valency of 2. So therefore, when you interchange, 1 goes to carbonate and 2 goes to sodium. So you're going to write Na2CO3 for sodium carbonate. So that's how you can apply valency in writing chemical equations. Now remember, this sodium carbonate is what we use in softening permanent water hardness, used to soften hard water, and sodium carbonate is used also in preparation of some chemicals like sodium hydroxide, which is used to manufacture detergents, also used to manufacture borax, and also used to manufacture sodium silicate used in glass making, and also used to prepare sodium phosphate, which are very important industrial chemicals. And this sodium carbonate is also used in the manufacture of paints, wall paints, which are used in construction and building. Now those are some of the chemical formula that I can give you for today. And keep watching, because in our next class I'm going to talk about chemical formula. More examples will come up on how to write a proper chemical formula. Up to that point, students, have come to the end of the lesson. If you like these videos, ensure you subscribe to this channel, and also ensure you hit the notification bell so that you can be notified when I upload a new video. Otherwise, for now, bye bye and see you next time.